All right. Greetings, YouTube. Beautiful mind here. So today we're going to continue with section 6.3. So we're here in our pre-cal class. This is for we're missing a few students today, so I don't know if they're watching the stream or not, but I'm going to go ahead and act as if they're listening. So our exam 2 is this upcoming Tuesday. There is a study guide. The time right now is 9:06. I think we talked about an extra credit opportunity. So when I started class today, I said the first 15 minutes, if any of my pre-cal students can show me evidence of their homework, I offer 30 bonus points out of the maximum 100 that we have for the quarter, just right now. So there's still about another 5 minutes left on the extra credit opportunity. But if I have evidence of homework, then I'll give extra credit for that. And so anyway, a huge amount of extra credit. So that's one thing. Also today, what we're going to be doing, so I think I have it here. Let me see. Where is this handout? Actually, let's go like this. So if we go to, so another thing that we're doing today, let's go to Pearson. So today we're doing something a little bit different. We're going to have an exit ticket, okay, for our class. So there's this document that's available on Pearson. So the first thing today is to go ahead and register for Pearson. So the pre-cal. So for the in-house audience, actually, let's go back. Don't show this again. So how to register for Pearson? We have this handout on how to register. It is located here. So this is how we register for Pearson. So today, while I was getting set up, I had the in-house students go through this document and go ahead and register for Pearson, okay? So we'll follow these instructions, and then there's going to be a point where you're prompted for an access code or for payment. We have a way to keep it free. At the bottom of that screen, we want to click on get 14 days of temporary access, okay? Let me see if I see it here. Okay, so right here in section 6, it says select an access option, either enter an access code. If available for your course, you see right there it says get temporary access, all right? Get temporary access. So we're going to use that route, and that'll give us 2 weeks of temporary access just for us to get some practice and exposure to Pearson. Okay, so if you're watching the video, you can screenshot this screen, but we want to follow these instructions and go ahead and register for Pearson. And for class today, the exit ticket, there's an exit ticket in there. So if you're in class today, you can actually go ahead and do it now. You can log in on your phone. All devices work. iOS works, Android works, laptops works, tablets work. If you can get on the internet, it works. All right. So go ahead. It's a quiz on there. It's going to say 6.1 and 6.3 exit ticket. Go ahead and do it. You get as many attempts as you want, but we need to, whatever grade you have at the end of class, that's the grade I'm going to submit, on in the grade book. Yeah, right? So, okay. So we have the exit ticket there. I can't think of anything else. Anybody have any questions? How are you all feeling today? All right. Are you excited about the holidays? We ready?
Yes.
What are you most excited about the holidays?
Getting out of school.
Getting out of school? Your birthday? When's our birthday? What is it? What you say? Right before Thanksgiving?
March 27th.
20. So what is that? You're a Sagittarius? That's what's up. Can you tell us a little bit about Sagittarius? I don't know anything about Sagittarius.
Sagittarius, I think they're really nice, good people. But like their bad side is
That sounds fairly accurate from my experience with Sagittarius. So I have an elder that's a Sag. I keep meeting Sagittariuses lately. Like it seems like almost out of nowhere, they just like a memo went out and they just all started popping up in my life at the same time. So anyway, okay. So today, what we would like to do, we would like to take some time to go through. We're going to continue chapter 6. So we're going to have an exam again this upcoming Tuesday. So the reason I have you all go ahead and register for Pearson. I have a study guide on there. I think Pearson is an invaluable resource, especially for this course of Precalculus. They explain every question. Every question has a view and example. Let's actually do a quick demo on Pearson. I just want you to get a sense of it.
Non-processing my what's name now.
Okay. So if we log into Pearson, and I'm going to pull up the homework for section 6.3. All right, just to do a quick demo on, let's see. So 6.3 Trig Equation. You see at the bottom there, we have 6.1 to 6.3 classwork exit ticket. So that's there. You get as many attempts as you want. Whatever grade you have at the end of class today, that's the grade I'm going to take. I'm going to insert in my grade book. So let's look at 6.3 really quickly. What's your favorite number 1 through 30? 3. Okay. Why 3? I'm curious. Third time's the charm. What is this the third time of? If you don't mind, your third time. You're like a cat. You got like 9 life experiences. Okay. That's not.
Don't listen to first.
That's okay. That's only natural. That's only natural. That's the human experience. We're all spiritual beings having a human experience. Okay. Okay. So now, here's one example, right? So this is a quick demo on Pearson. All right. This. What is that number in the upper left hand corner? It says 6.3.3. What does that mean?
That means it's unit 6.3 and the third number.
The third question, right? So it's chapter 6, section 3, question 3 from the back of that section, right? So it's section 6.3, question 3. This question says, find the real solutions of this. So we have this quadratic, right? How would we find the solutions of this? I'm curious. What would you do? What would Jesus do?
What would Jesus do?
What would Jesus do in this case to find the real solutions of this?
Yeah, I was just going to say that.
Factor? I think Jesus would do that, right? Okay, so it is time for a poor joke. Did I tell you the joke about the Jesus and the devil in a typing contest? Did I tell you that joke? So the Jesus.
It better not be like that knock joke. Wait, was it a knock joke?
There was a bad.
No.
Look, I gave you fair warning. I said it's time for a poor joke. Okay, so I always premise it with that. So if you don't like it,
That joke was.
So okay. So it's time for a poor joke. It's time for a PJ. All right. So the Jesus and devil were in a typing contest. This contest. The winner of this contest was going to save all of humanity of all time. Right. So it was a no holds bar, head to head. Everything goes. They're going for broke. This is to save everybody. So the contest begins and they're going at it. I mean, they're going like really hard, like it's a typing contest, type. I mean, they make mistakes, they edit on the fly. Some people, they just going really, really hard, and they're going, and then it's getting down to the wire, and they're just about to finish the result, and you know what happens? Just like that, you know what happens?
They die.
The power goes out.
Oh my God.
So they were right in the heat. They were right in the heat. They were right in the heat of the contest, and they were about to see the winner, and it's just about to end, and the power goes out. But you know who won, right?
God, Jesus.
Why did Jesus win?
Because Jesus is the only person that can save somebody.
Because Jesus saves.
Exactly. The devil don't save.
You get it? It's a
No.
typing contest. So the reason Jesus won the typing contest is because he saves. Okay.
The devil ain't saving
Okay.
nobody. I know that.
Yeah, it's a PJ. Okay, one more bad joke, just in the same spirit. Okay, go ahead. Okay.
Why did the chicken cross the road?
So
To get away from Popeyes,
to get away from Popeye.
because
You know they have
So
a
he wouldn't
chicken
go to
on the
church?
road for real. in
chicken.
Popeye.
Oh, church is chicken, so he can go to church,
Why did the chicken cross the road?
so he can go to
to
church.
get to the other side.
Is that the legitimate answer?
What?
That's the only reason why he's gonna be crossing the road.
What?
I'm pretty sure he don't want
Who knows? It's a chicken. Like chickens.
Right.
Like,
Chickens have-
okay, one more, then we're gonna get back on task. Okay, and it's in the same spirit of religion, not crap, but religion. So, let's see. So this is a riddle. This one goes. Did I do this one? What's greater than God, more evil than the devil? Did I do that one? So what's greater than God, more evil than the devil? The poor have it, the rich need it, and if we eat it, we'll die. So what's greater than God, more evil than the devil? The poor have it, the rich need it, and if we eat it, we'll die.
Nothing's greater than God. The poor have it, the rich need it.
So what's the answer?
Nothing.
There you go, because you actually said it. You didn't even realize it.
God.
Yeah. So what's greater than God?
Nothing.
What's more evil than the devil? What do the poor have? What do the rich need?
Nothing.
Nothing. What if we eat, we'll die?
Nothing.
Okay.
Start
So
with that.
okay.
Skill one.
Okay. So not too bad. You know, if we keep working at it, eventually we'll get it. What we practice, we'll get really good at it. So you know, whatever we practice, we'll get good at. So now, speaking of practice, let's go back to this, right? So the suggestion was to factor this. So let's do a quick. Is this the right? Is this right? This might be the wrong. This is pre-cal. Okay. So let's factor this and do a quick demo on this. So I'm going to get a copy of this, and I'm actually going to load this copy into my note-taking software. I'm just going to cut off. I just want this part really, and I want that to actually go right there, just like that. Boom. Okay, and this is just to try to change up the energy and the rhythm a little bit today. That's fine, just like that, and let's go here. Okay, so we're asked to find the real solutions for this, and there was a suggestion to factor this. And actually, you know what I'm going to do? I'm going to crop this even further and just focus on what I want. I really just want this. Boom. Come on, thank you. Okay. So again, so this question comes from 6.3, question 3. This is just a demo on Pearson and like what I anticipate people to do for the homework, right? What color you feeling? Give me a color.
Yellow.
So I'm going to do orange because yellow is hard for me to see. Yeah. That's okay. So now, and actually I like to do this. Let's go paper. And I like my graph paper. It just makes me feel better. Okay. So the original we have is 5x squared minus 9x minus 2 equal to 0, right? Okay, so we want to factor this. Can you walk me through how would you factor this? What would you do? Two numbers that two numbers that multiply to give us. So right. Yes. Two numbers that multiply to give me. Keep going. 10. Almost. Not 10, but not 10, but. How did you get 10? 5 instead of 5 times 2 is 5 times. Negative 2. So two numbers that multiply to give us negative 10. Okay. So two numbers that multiply to give us negative 10 and add to give us negative 9, right? Let's go down the list. So first we have negative 1 and 10. What does that add up to? They add up to positive 9, right? So what do you think we might need to do? Switch the sign. So instead of negative 1 and 10, let's do 1 and negative 10. Are these two numbers that multiply to give us negative 10 and add to give us negative 9? Okay. So these are our two numbers that we want. So now I'm going to use this technique. I got this from some students in the past and from YouTube. I'm using a technique called the box method. So what we're going to do, we have, let's do this color. So we have this box. I'm just going to kind of go like this. That's fine. That's good enough. I don't like that at all. I don't know. I'm going to delete it. Just ignore what you saw. You didn't see anything. So I'm going to do this box. Right. Watch this. Just like that. Go ahead.
I was looking at my grades on
Okay.
Are they updated?
They are not updated. So let's get through this exam and then we'll take a day or two to kind of make sure everything is in order. Because I know I have some assignments here. We're gonna that's what my goal is today, to get through as many of these as we can. But the first thing that we really need to do is finish section 6.3. And then once we do that, we can look at the study guide and any outstanding grades, right? And I'm kind of open. I'm not really trying to be super strict about anything. So what we're going to do, in the upper left-hand corner, we're going to put this, let's go back and put it back to there. In the upper left-hand corner, we're going to do 5x squared. In the bottom right-hand corner is the constant term. And then the two numbers that we just found, they go here. We're going to rewrite that negative 9. We're going to rewrite this negative 9.
So 1 and negative 10.
Right, all right. So we're going to say that 1 times x is just x. And negative 10x. So we rewrote that negative 9 as 1x plus negative 10x. Is that okay? Mm-hmm. Okay, so now, if we look at the two on the top, the orange and the purple, the 5x squared and the x, what do they have in common?
The x.
They both have an x, right? What do the two on the bottom have in common?
The negative. They both
Negative what? Or the GCF? What's
negative
2? You got it. You know what you're doing. What do the two on the left have in common? They both have x, and what else? 5. What do the two on the right have in common? Nothing. So we're going to put what number?
0.
1, right? 1.
How come?
Because that's the only thing they have in common.
Oh yeah.
Okay.
Because the 1 in front of the X.
Is that okay? Because, yeah, we don't do 0. That's going to really mess things up. Yeah, that's going to mess it up. Okay, so then our claim is that the original actually factors into, so let me get a copy of the original, or we can do it right there. So our claim is that the original factors into x minus 2 times 5x plus 1. So we're saying that the original is actually this. Do we agree with this or do we disagree? How can we check this?
You do the box method or foil.
If we foil, right? What's 5x times x? Give me a color. Blue. Give me great minds. Think about math. Okay. So give me a random object. A trapezoid.
Yeah.
Okay, we could do a trapezoid.
You should have done a flute again.
A flute?
Yeah. You know how to draw a flute?
Yeah, we can draw a flute. We're going to draw a trapezoid flute. So what we're going to do like this. We're going to do like this. Hang on. So we're going to do like that. So this is a flute. So we're going to kind of come like this, like this. It's a flute, so it has a little slash like that. And then it has like, let's do like this, like that maybe, like this. We're going to go like, let's go like this. These are those little dots or whatever. And then we're going to have a little opening for the sound. Let's clean that up a bit. Yeah, that's better. That's our flute. That'll do for now. Give me one other color.
That looks nice. Red.
A blue-red flute. Okay. I'm going to go like this. And we're going to put this. This is a flaming flute? I don't know. We just added some color to it. It's okay. Okay, so now we're going to take this and we're going to kind of go like that and we're going to shrink it down. Okay, this is going to be a flute. And really quickly, don't want that. Let's do like this, like this. So since it's a flute, we got some musical notes going.
Oh, that's the little music, the keys.
Mm-hmm. Music, and a few other little musical things. And then a treble clef. This is my best rendition of a treble clef really quickly. Something like this, treble clef.
I hate that. I can't draw that.
Yes, you can. You just got to practice. Because honestly, you can do anything. You just, okay, I like this. And it's music going off. Okay.
Yeah, that looks nice. See?
Okay, so this is our cursor. All right, so just to draw some attention and just to, let's kind of go like this really quickly. I just want that point. That's fine, that'll work for me. Okay, so we got our musical flute. Side story, okay. Have you ever gone like Googled your name or anything and like looked at the meaning of your name? I was at a party and I looked up mine. There was an Urban Dictionary one and I kind of ignored it. But when I looked at my name, do I want to say my name on the web? I don't really care. I don't have nothing to hide. So my name is Charles Edwin Pfeiffer, right? So when I look up Charles comes from like German, that's like means manly. And then when I look up Pfeiffer, my neighbor brought this to my attention. When I said Pfeiffer, he was like, what did he say? He said, oh, fife, like a flute, like a leader. I was like, oh, so my first name means man, my last name means leader, and my middle name is Edwin. Edwin means like rich or blessed friend. So then when you put my name together, it means rich or blessed friend who is a leader of men. And I didn't realize it, but then I found myself, I taught at Morehouse for like 5 years. I definitely am rich or blessed, like in some sense. I don't have a lot of resources, but I'm very resourceful. I know how to get what I need when I need it. But the fact that I was teaching at an all-guys school, I was leading men. Like I was actually living what my name meant. And when it dawned on me, I was like, oh my goodness. Like it just blew my mind.
My name's too long to be looking at.
Well, but so when we said the fife, the flute, it made me think of my last name because you have your musician or a leader. Fife is like you can like the Pied Piper kind of thing. Not that, but you know, it's a leader or a musician. So you know, so there's power in these words that we use, especially our names, and when you know what it means, you can actually it's natural for you to do certain things. Okay, so now. If we want to confirm that this, so now we have a cursor, we want to confirm that this is the same as the original. If we FOIL, x times 5x is 5x squared, so that's okay. Outer times outer is 1x, inner times inner is negative 10x, and they add up to negative 9, so that works. And then last times last is negative 2. I really like our cursor today. That was a fun little adventure. Okay, so this factoring is good. Now, there's a property in college algebra that says when more than one thing multiplies to give us 0, what does that mean? Either there's a thing called the zero factor property. So the zero factor property basically says either the first, either, I think I used that one. Either the first thing equals 0 or what?
The second one.
Or the second one equals 0. If we solve the first one, x equals what?
X is equal negative, well, 2.
Right.
You got to do inverse operation.
Right, so add it to both sides. Or can you tell me the other one, x equals?
0, because 5x can't be factored.
Solve, right? If we solve for x, what are we going to do to solve for x?
You're going to move 1 over.
Okay, how do we move the 1?
Inverse operation.
What's the inverse operation?
It's negative.
I like you just taught me something because I'd never said it that way. But I've never said use the inverse operation, but I'm going to try it out to see if that vibes with my students better. So a number plus its opposite adds up to 1 plus negative 1 is 0 because you've been using 0 all day. 0 minus 1 is
-1.
Okay. So now can you tell me what is x equal to? What's the next inverse operation?
You will have to divide.
Divide both sides by
X by 7 by 5.
divide both sides by 5, and the result is x equals okay, -1/5. Okay. So we got results of x equals, what do we say? 2 or -1/5? -1/5, comma 2, right? So now our claim is that this is the result. How can we check that this is indeed the result?
You can input it.
Okay, I heard input it. So what do you mean by input it?
You can use one of the x's and input it into the equation.
Okay, give me just a moment. All right, so we should check both, right?
Yeah.
Come on.
It will be easier because it's not,
All right, so let's look at this. All right, so we're gonna go like this. We still got that open. We're gonna do a new one. Let's look at our calculator. Come on, thank you. All right. Let's reload and refresh really quickly. So we have a graphing calculator. We can check this really quickly, really easy in our graphing calculator. So I'm going to go to y equals. We're going to type in the original 5x squared minus 9x minus 2. All right, that's the original. I'm going to quit. Now, you see, the clear button on the far right-hand side? Next to that is VARS. I think it stands for variables. I'm going to click on that.
I was just going to say what's my calculator.
Okay, I got variables to the right. I'm going to click on y variables. I'm going to click on number 1, and I'm going to click number 1 to call the function that we just typed in, right? So now, we're saying when x is a -1/5, what should be the output? So if we plug -1/5, it should be 0, and that was clear. Okay, let's do the other one. When x, instead of -1/5, when x is what? 2, what should be the output?
It should be 0.
See how quick and easy that was? Is that okay? So now we're confident in these answers. Let's go back to Pearson. Again, this is all just a demo on Pearson. So now it says select the correct choice below. So we're going to put in the first one, and we got results. It says simplify your answer, type an exact answer using radicals as needed, use commas to separate answers as needed. So we got negative, where's the rest of it?
We got 2 and -1/5.
We got a -1. Where is my keyboard? Is acting a little bit funky. Oh. Hang on. Let's go like this. Let's go to on-screen keyboard. Let's turn it on and hit OK. Come on. There it is. That's what I'm looking for. Okay. So we got a negative, what was it? 1/5? Is that right?
Mm-hmm.
And then the second, we're going to hit comma and 2. Okay. I think this is it. Let's hit enter, cross our fingers. Awesome sauce. Now, so let's look at that one again. Suppose we wanted more practice. In the bottom right-hand corner, we have that link that says similar question. I'm just going to hit that again if we want to practice again. We still have our credit. You see the check in the upper left-hand corner. This is the same question with a different algorithm, right? So I'm going to go to question help. Suppose we didn't know what to do. We have the help me solve this. I don't really recommend that one. The view and example is very powerful. There's an e-textbook. This one also has the Ask My Instructor. So like if we weren't sure, we could click on Ask My Instructor, and it'll pull up the exact question, and it'll send me a screenshot of the very question you're working on, same numbers and all. And then I'll load it to my tablet, and the same way I'm streaming here, I can communicate long distance. So it's like, as we have questions going through the homework, if you wanted to ask me, you can click on the Ask My Instructor, and I make dedicated YouTube videos walking students through any questions that they ask. But the first thing is, gotta get the students to start asking questions, because if I give you answers and you're not looking, you're gonna miss it. You see what I'm saying? So, but it's mainly this toolbox here is why I advocate for Pearson. So we actually have this same thing available for this pre-cal course. So I'm just bringing it to everybody's attention, to your awareness. So let's click on the view an example really quickly. So, oh no. So we have this, and so now the view an example is powerful because it gives us a similar question, different numbers, and basically it walks us through step by step, and you'll see they're essentially doing the exact same thing we just did on our own. Does that make sense? So, we've had this kind of power at our fingertips all the while, but I've noticed that, like, okay, we haven't been taking advantage of it. So I was like, let me shift gears and bring it to your attention, right? So this is why I advocate for Pearson, especially for something like pre-cal, because every question has an explanation right next to the question. You just have to know where to look. Okay? So, yes, come on. Yeah, here at the bottom, we have this thing that says 6.1 to 6.3 classwork exit ticket. So that's what I want you to work on. So you can kind of go ahead and get started. Were you all able to register okay and get into it?
Yes, I'm in.
Have you already done the assignment?
Not yet.
Yeah. So you can go ahead and do it. So that was a demo on Pearson, right? Okay. Yeah, that quiz. So let me open up the quiz section. So if I go back to the top and I switch it over to just quizzes. So right there at the top, it says 6.1 to 6.3 classwork exit ticket. So you get as many attempts on that as you want. Whatever grade is there at the end of class today, that's what I'm going to put in my grade book. And so now I'd like to go back to, let's start the lecture for the day. Not there, yeah. Okay, so let me pause for the cause for a moment. Do you all have any questions? Do we have any questions about anything? Okay. So today we're doing 6.3 Trig Equations, okay? So some objectives, let me see, how many slides? Okay, not too terribly bad. We want to look at solving equations involving single trig functions, solve equations using a calculator, solving trig equations quadratic in form. So that's like how we did in a quadratic equation already. So that was a good little review. Solve trig equations using fundamental identities, solve trig equations using a graphing utility, okay? So these are some of the objectives. So first let's take a look at solving equations involving a single trig function. So in this example, we're asked to determine whether theta equals pi over 6 is a solution of the equation this. Is theta equals pi over 3 a solution? So in order for these to be a solution, what should be the case when we do what with these? So it says determine whether theta equals pi over 6 is a solution. Also, is theta equals pi over 3 a solution? So if it's a solution, if it is a solution, what does that mean? If we yes, it should make it true, right? If we plug these into the original, it should be true. If it's not, then it's not a solution. Okay. So what I'm going to do, I'm going to get a copy of this. And I just want, we can go there, there, there. And I'm going to load that right here. Right there. All right. And then let me crop this really quickly. Come on. Right there. Done. And then I'd like to pull up my calculator. I'm just going to plug this in the calculator. Now you can do this by hand. It didn't say we can't use a calculator. So for the sake of time, I'm just going to use my calculator here. So my calculator is here. All right. It's fine. So what we're going to do, what mode does the calculator need to be in? Okay, we are in radians. So let me go to mode really quickly. We are in radians. I'm going to go to y equals. I'm going to type in the original. I'm going to type 2 sine. I'm going to hit x, 2 sine of x, minus the square root of 3. And that's the whole left-hand side. I'm going to quit. And basically, I'm going to call that same function that I just used. So now, what's the x for the first one? Or third theta for the first one? The first theta? So I'm going to just type pi over 6. And what result are we anticipating? If we plug, if pi over 6 is a solution, if pi over 6 is a solution, what result should we get? We should get 0. We do not get 0. So what might be the case? That it was what? No. What can we say about pi over 6? Is that a solution, yes or no? It's not a solution. So the first one we would say no. Let's go ahead and just really quickly try the second one. We're going to do pi over 3. Again, if it is a solution, what kind of result are we anticipating? 0, and we got it, right? That's all. It didn't ask us to solve. It just asked us, is this a solution, yes or no? It didn't ask us to solve, right? Is that okay? Okay, give me just a moment. So let's make sure that this actually worked. So the first one should be no. So therefore, pi over 6 is not a solution, okay? And the second one should be yes. Therefore, pi over 3 is a solution. Okay, can y'all see that? Y'all can, but that's not what I want. We want this one. Can y'all see that? Okay, cool. That's actually working this time. So there was a request to see how we, now, you want to see the whole thing in the calculator again? So first we hit y equals in the upper left-hand corner. You have it? Are you on a TI-8? What kind of calculator are you using? Let me see it. Is it a graphing calculator? It's not graphing? So yours would be different than mine. You'd have to figure yours out. Yours is going to be different than mine. No. So you would have to take time to figure out how to do it in yours. Let's kind of keep going though, since we have different calculators, okay? And we'll come back to it. Okay. So we saw those two. So unless the domain of the variable is restricted, we need to find all solutions of trig equations, all right? As the next example illustrates, finding all solutions can be accomplished by first finding solutions over an interval whose length equals the period of the function, then adding multiples of that period to the found solution, all right? Okay, let's see this in action. So we're asked to solve the equation cosine of theta equals square root of 2. Give a general formula for all the solutions, and then it says list 8 of the solutions. Okay, so I'm going to get a copy of this and go back to my note-taking software. So we have that, and I just want this, and I'm going to go like this. Okay, and I'm going to load that here. Okay. What color are you feeling? Green is fine. Crop, and hit OK. All right. Okay. So we're asked to find all the solutions of this. So we have cosine of theta equals root 2 over 2. So we have cosine theta equals square root of 2 over 2. Okay. And let's go paper. I like my grid paper. So we want to solve this. Okay. So can you tell me an angle? So first of all, we notice we have cosine. So on the unit circle, cosine, is that our x or is that our y? That's our x. Is this result positive or negative? This is positive. So what quadrants is x positive? 1 and what else? 4, right? So x is positive. So what we're saying is that there should be a quadrant 1 solution that should make this true. There should also be a quadrant 4 solution that should make this true. Does that make sense? Wait. So wait. Before we get there, but does it make sense that there should be a quadrant 1 and a quadrant 4 solution? Okay. So now let's just focus on quadrant 1 first. All right. So now, if we're focusing on quadrant 1, can you tell me cosine of what angle gives us a square root of 2 over 2?
Yeah, 45.
45 degrees, right? Okay. So in quadrant 1, that would be 45 degrees. Let me see. More than likely we have to do this in radians. So we'll convert to radians at the end. Let's do everything in degrees first, and then we'll convert to radians in the end. So that's the quadrant 1 solution. Now, cosine repeats how often? So how many degrees until cosine starts repeating again? 360, right? So every 360 degrees, cosine repeats. So if we're at 45 degrees, if we do a complete revolution, then what happens? We're going to find what? Another solution. Does that make sense? So every time we do a rotation, either clockwise or counterclockwise, we get another solution, right? So that's the quadrant 1 solution. So the reference angle is 45 degrees. So can you tell me the quadrant 4 solution that should also have the same result? How did you get 315? Okay. Okay. So if we're at 45 degrees in quadrant 1, we said there should also be a quadrant 4 solution. So that means we need to be in quadrant 4, but 45 degrees away from the x-axis in quadrant 4, right? So whenever we're 45, the answer is the same. We just have to get the right quadrant. So if we're at 360 and we drop down by 45, then 360 minus 45, what'd you say, 315? So then the quadrant 4 solution is going to be 315 degrees. Is that okay? That's like negative 45. Okay. So wait, there's one more step. So now we need to account for the complete revolutions. We said it repeats every 360 degrees. So from the quadrant 1 solution, if we want to generalize and capture all the results, every time we're at 45 degrees in quadrant 1, that's a solution, plus 360 n degrees. Every time we do a complete revolution, where n is going to be an integer, either positive or negative, right? So it doesn't matter. Like n, it's just, this is a generalization. So this will capture all the quadrant 1 solutions going. Like if we go clockwise, if n is 1, right, then we're at what? Whatever. That's 405, right? Every time we do a complete revolution, does that make sense? So that captures all the quadrant 1 solutions. If we want all the quadrant 4 solutions, can you tell me the quadrant 4 solutions? 315 plus 360 n degrees. Does that make sense? So let's go ahead and convert this to radians. So if we do this in radians, theta is going to be, wait, before we do that really quickly, it also asks us to, find 8 solutions, right? So let's just find 4 from each. Okay. Okay. So if n is 0, we get 45. If we're in quadrant 1, keep going. If n is what? 1, okay. Is 405. Okay, that's the second one. That's fine. It's fine. Okay. Let's get one more from there. Okay, degrees. So let's keep going. Let's get 4 from the other one, from the quadrant 4 solution. Okay, that's fine. Okay. $10.35. Give me one more. Okay, $13.95. Okay. So now we decided on these 8 solutions. Let's go ahead and convert these to radians. Let's get exact. You know how? Can you tell me how to get exact value? Convert these to exact radians. So, okay, the 45. I'm listening. Just talk me through it. So we want to convert 45 degrees to radians. Mm-hmm. Okay. So let's do. I heard 45 degrees over 1. Pi over 180. So degrees, the units of degrees are going to cancel. Okay. So then So what's 45? Let me see. Hey Siri, what's 45 degrees in radians?
45 degrees Fahrenheit is 7.2
She didn't
degrees
do it
Celsius.
right. Hey Siri, what's 45 divided by 180 as a fraction?
45 divided by 180 is 0.25.
What's that as a fraction? A fourth, right? So this is going to be pi over 4. Is that okay? So we got pi over 4 is the first one. Can you give me the rest as radians? As a fraction like this, exact radians?
So I got
9 pi over 4. So really quickly, we did a complete revolution, right? If 360 degrees is a complete revolution, what's a complete revolution in radians? 2 pi, right? So if we said 1 over 4 plus, or pi, if we said 1 pi over 4 plus 2 pi over 4, sorry, what's 1 pi over 4 plus 2 pi? We got what? So look at this.
1 pi.
So wait. So remember, we're just adding complete revolutions, right? We said a complete revolution is 2 pi, right? So we started with pi over 4. We're going to say plus 2 pi. Let's get the common denominator. This is the same as 1 pi over 4 plus 8 pi over 4. Is that okay? What does this give us?
9 pi.
Okay. So let's add another revolution. What's the complete revolution going to be?
2 pi.
2 pi. And let's go ahead and keep the common denominator. That's going to 8 pi over 4. What does that give us? 17 pi over 4. Is that the 765? Okay, so can you tell me the next one? If we just did 17 pi over 4, we're going to say what? Plus what? In this case, it's going to be 8 pi over 4 to give us pi over 4. Is that the 1125? Is that correct? Is that okay? So now let's do the 315. Let's convert 315. Let's convert that to radians. So we're going to say times pi over 180. So then, hey Siri, what's 315 divided by 180?
315 divided by 180 is 1.75.
So what, 7 over 4? Is that 7? 7 over 4? So this is the same as 7 pi over 4. Is that okay? Keep me honest. Don't just take my word for it. Is this okay? 7 pi over 4. So now, how do we generate the rest of them? We're going to add what every time?
45. No.
What do we add? What do we keep adding? We're adding 2 pi, and it's the same. That's the same, right? We're going to add 2 pi, which is essentially 8 pi over 4 each time. So if we add another 8 pi over 4, so what is the next one?
After 7 pi?
Mm-hmm. So we're adding there it is, 15 pi over 4. Give me the next one. 23 pi over 4. Give me one more. 31, right? 31 pi over 4. See how quick and easy that was? Well, I don't know how easy it was, but it definitely was quick once we kind of got the rhythm. Now, let's do a quick check to make sure that these actually work out, all right? So the original, let's go back to the original. We had cosine of theta equals root 2 over 2. So what we're going to do, we're going to open up our trusty dusty rusty, what? The calculator. Okay, we're going to open it up. We're going to go to y equals, actually, we already have that. So that's already a function. So we're just doing cosine of theta. Now the answer should be square root of 2 over 2. So I'm going to just hit square root of 2 over 2. We get this decimal. So if we get this decimal when we plug these in, that means we did it right. Does that make sense? Okay, so now we're just doing cosine of each of these. So let's just check them really quickly. We're going to do cosine of, make sure mode, we're in our radians. We're going to, what's the first one?
Pi over 4.
And what answer should we get? That 0.7. We got it. Let's do the next one. Cosine of what's the next one? 9 pi over 4. And we got it. Let's go ahead and do cosine of 17 pi over 4. Awesome sauce. And let's go ahead and do cosine of 25 pi over 4. Is this okay so far? Y'all see it? Hang on. Let's do cosine of 7 pi over 4. I just want to make sure these are all good. Let's do cosine of 15 pi over 4. Awesome. 2 more. Cosine 23 pi over 4. And to bring it on home, cosine of 31 pi over 4. And every time, right? And yeah, we started out by saying that 0.707 is the square root of 2 over 2, which is, you see it right there on the right-hand side of the equation. Is that okay? Does this make sense? So this is sensible stuff. It's just, we have to practice, right? So we do have the exit ticket that's still on, and I'm actually open to, if my students are far away listening to this lecture and they actually do the exit ticket, if they do it, so I don't know if you want to send them a quick text like, hey, there's an exit ticket on Pearson, you know. I don't know if y'all want to do that or not, but if they get it submitted, when I go to look at my grades, if it's there, whatever grade I see, that's what I'm going to use, right? So it's open to everyone. This is why I've been doing this presentation, because even if we're not physically here, if we can access the internet, which isn't too difficult in this day and age, if we can access the internet, we can still do what we need to do. Does that make sense? Okay.
Okay, this seems like it might be easy. And then you're gonna add some letters.
Of course. Okay, so let's just take it step by step and moment by moment. So we have our solutions. We got something. These all worked. Let's go ahead and kind of be consistent. Let's get these to be the same. We're gonna go style in orange. Now let's see how the notes approach that question. Okay, so the exercise is solved. It says list 8. It says the period of cosine function is 2 pi, so it repeats every 360 degrees. Notice they're saying there's a quadrant 1 solution, and the reference angle, and there's also a quadrant 4. Because on the unit circle, cosine is our x, and x is positive in quadrants 1 and 4. So it says cosine repeats every 2 pi radians. So on the interval from 0 to 2 pi, there are 2 angles, pi over 4 and 7 pi over 4. Those are the 2 angles that we solved for that made this true. So because the cosine function has a period of 2 pi, all the solutions of cosine of theta equal root 2 over 2 can be given in this general formula. We took the first angle plus integer multiples of 2 pi. And then the second one we said was 7 pi over 4 again, plus integer multiples of 2 pi. That's essentially what we did. We took it and we kept adding the 8 pi over 4. All right, is that 8 pi over 4? Is that okay? So then I think they did the negative and the positive, which is fine. This is essentially the same thing that we got. If we look at ours, we at least have half of this list. Yeah. Does that make sense? And I like the way they did it. They did the plus and the minus, but it's the same kind of deal. It's the same deal. Yeah. There are infinitely many solutions, so we just had to make sure that ours were correct. Okay, so that was us checking that our solution was correct, right? That our solutions. So these were the solutions that we got. We plugged all of these. We took the cosine of all of these angles to make sure that we got root 2 over 2, right? So that 0.7 was the root 2 over 2. This is actually really good today. This is better. I know the last time I was a zombie, I was barely able to keep my consciousness. I was about to fall asleep while I was talking. That's how tired I was. I was so tired. So I'm gonna have to redo that video lecture. The night before, I just did not go to sleep. It's just the time change always throws me off.
What's going on?
It's the time change. Look. Yeah, now I don't know. Now time does seem to, if we talk about time, right? It does seem to be speeding up. I don't know if it's because we're getting older or if it's actually speeding up, but it just seems like there's not enough hours in the day to just, it's like you focus to do one thing and then everything is over. The day is over. I don't know if time is actually speeding up, but I don't really believe in time. Like, I don't think it's real. Like, what do we mean by time? Like, the essence, the fabric, what is that? Because if time was so constant and so immutable, how do we change the time twice a year? Is it?
How do we go back an hour
so,
dark as
so you know what I'm saying? It's like if we can change the time, then that means it probably isn't even real in the first place. You see what I'm saying? So, and I'm like, to me, I'm like, what's a Wednesday to a squirrel? What's a Tuesday to a dog? It's either the sun is up or the sun is down. You see what I'm saying? Like, but you know, like if you look at studies, there are studies where there are a high number of deaths Monday morning at 9 a.m. Like I think it's like the highest number of suicides at that time because people are stressed out about going to work and getting there on times, stressing about things that don't even exist, that's not even real, that ain't got nothing to do with the price of tea in China. You know, people are stressed out about this time factor, but that's because it's a man-made construct. At least that's how I feel about it. I'm not an authority on the thing, but that's just how I feel about it. What time did we get out of here today?
10 minutes.
We got another hour, right? We got another hour, right? Go ahead.
I think time is like a measurement.
It is. It's a measurement of cycles, right? I feel like something that might be a little bit more appropriate is like, okay, what cycle? Like talk about cycles or something, because it's like, but I was listening to something. I don't know if it was Jim Rohn or some kind of like self-help talk, but he was like talking about the future. Some people had approached him. People had approached him. How's it going? Had approached him and asked him, well, what do you think is going to happen in the future? And he was like, well, whoever the presenter was like, well, I'm pretty sure if you want to get a sense of the future, it's going to be about the same as what it's always been. Because after winter comes what? Spring. After spring comes, and after the summer comes, and after fall comes. And that's been going on. That's a cycle. You see what I'm saying? Like you might have different extremes of it, but that's typical. And life is pretty similar. Like we're born, we have an experience, we either like it or we don't. It's cycles, you know. And we get hungry, we eat, you know, we have to kind of satisfy, you know, the life, whatever. And so it's like, so what I've personally done is like, I've abandoned time. I consider myself a master of time. Like when I need to be on time, I know how to do it. I usually get places early, and I'll take the remaining time for my personal stuff to like meditate and stuff like that. But I don't really adhere to it. I try to be where I need to be. I use it for like organization. So like when I'm meeting up with people, I was like, okay, I'm a stickler for time. I'll get places early so that we can be in sync, so our cycles can match up or whatever. You know, I know that's a very funny statement, but I use it for timing and like organization. But I don't really believe in it. I don't think it's a real thing. Like other than either the sun is up or the sun is down, what cycle or what stage in life are we at? But you know, at its essence, I adhere to the fact that I'm an energetic being. I'm consciousness, and right now I'm inhabiting this body, but I don't really adhere to this body. Like that's how I feel, you know. And so sooner or later, I'm going to fall from the body, but my energy, my essence, my consciousness was going to keep going. If you're Christian, Christians typically believe in heaven or hell. But if you ask me, we're in heaven and hell now. Heaven and hell is a reflection of our mental state. If we're angry or upset about something, we experience hell. You see what I'm saying? Like right now, some people are like depressed because it's cold outside, so they're experiencing hell. But some people love this weather. Some people love this time because you got the leaves are changing when it's cold. It brings people together. There's like family. Then you got like hot chocolate. Again, that's our mental state. So our mind is creating heaven or hell, right? If we can find some light to get excited about, then we create heaven. My studies have shown in that Christian sense, if you do adhere to the ideas of heaven and hell, even if you fall from this body, that state or that existence is in direct correlation to our emotional state. So when we take charge of our emotions, we take charge of our reality, whether in this life or the next. You see what I'm saying? That's why I study mathematics. My nephew taught me that in this video he sent me. It's called The Laws of Eternity. It's an animated movie, but that's where I first came onto that notion that our emotions, and this is another reason why I stream on YouTube, because I've been wanting to log these kind of conversations so I can have it on file. But our emotions dictate our reality. So if we want to take charge of our reality, if we want to change it, we got to take charge of our emotions. Have you ever come across somebody and like you're just fine going about your business and they're in a bad mood and then they start picking on you?
Yes,
And then they get you in a bad mood. Have you ever been around somebody and they're like, why are you upset? Like, I'm not upset. What are you talking about?
Right.
You are upset. Look at it. And then they keep asking you.
My face make it be looking like I'm upset.
But you don't. That's just your resting face, right? And so, you know, that's honestly how I feel like Trump got in office. Not that it's a bad thing. That's just the route that he chose to take as far as the power he chose to take on. He decided to use the power of fear, and because fear is kind of easy to get into somebody's psyche. The average person, it's kind of easy to get them focused on, oh, we need guns and we need to protect ourselves. Oh, I'm afraid of death. But when you abandon your fear of death and you start to identify with the true aspect of yourself, that your energy, water cannot wet you. So I'm getting this from Deepak Chopra. Deepak Chopra is a neurosurgeon. He's from India. He's a neurosurgeon. He studies consciousness, and he puts a Eastern philosophy spin on it, but it's legit. He's like fusing spirituality with science, and I love it. I can't get enough of it. That's what I do with my mathematics. This is why I study mathematics. Mathematics is synonymous with spirit. To me, I don't see how you can be a mathematician and not have an appreciation of the spirit, because mathematics, we just do nothing but sit around and talk about things we can't see day in and day out. We talk about all these things that we can't see, is not tangible, but how come, if we can talk about all these ideas and concepts that are intangible, why can't there be beings in other dimensions that are intangible? And there's merit to this, because how do you explain, like how is it that our devices are able to pick up all these? How do you explain the internet and electricity?
Exactly.
Like, how is it that means that information, those realms, we're surrounded by it, but we're just not in tune with it. So we use these devices. These devices are manifestations of our natural abilities, but these are distractions. So because we're so focused on the technology and the phones and stuff, we start to lose our ability to tune into those realms naturally, right? The calculator is a personification of our natural abilities. But when we think that we don't have any power, we externalize it and we call it God. We call it something that's external. We're like, oh, I can't do it because I don't have my calculator. It's like, no, you are the calculator. If you go to YouTube and type in human calculator, there are so many fantastic things that people have, techniques and things of that nature. I mean, I'm going to bring this on back. So Deepak Chopra, he would say, what was it? So when we identify with, like, only reason we have like ego and anger and hostility is because we identify with things that's not really us. When we identify with our skin, our hair, our political status, our career status, whatever status we identify with is not really us. I am not a professor. I am not a mathematician. I am not black. I am not any of these things. I am experiencing being black. I am experiencing being a mathematician. I am experiencing being a U.S. citizen. I am experiencing my kinky hair. You see what I'm saying? But I'm not these things. I'm just having this experience. You see what I'm saying? There's a difference. So it's like when somebody tries to call you out of your name, it doesn't really mean anything, because that's not who you are. Even if you're not behaving a certain way, like, I'm not bad. I'm just having this experience. So then it's like so whenever we kind of like fight and argue and stuff like that, it's because we identify with something that's just simply not true. But when we identify with that aspect of ourselves, now this is the part that comes from Deepak Chopra. When we identify with the aspect of ourselves that's timeless, it's eternal, water cannot wet it, fire cannot burn it, weapons cannot cleave it, it's timeless, it's soft, it's eternal. When we identify with the aspect of ourselves that's like that, in science it's called energy, in religion it's called spirituality. Some people just don't give it a name at all. But there's this aspect of ourselves that you cannot deny. There's some exercises we can do, and I'm not going to do it right now because I'm doing my best to bring it back on time, back on task. But when we start to identify with the aspects of ourselves that's eternal like that, and you can convince nearly anybody that they're eternal. If you talk to a Christian, they believe in heaven or hell. Once you get past the fear of death, once we abandon this fear of death, and we know that even though we fall from this body, we're going to keep going. A Christian, we go to heaven or hell. I think Muslim is heaven or hell. If you talk to Hindu, they believe we're going to come back, reincarnation. So that has to be at least 80%, some huge number of the population. But if you talk to a huge portion of the population, you can convince them that their essence, their true self, they're going to keep going. Even though we fall from these bodies, that's not us. When our car is done, we just go get another car. When these bodies are done, we just go get another body.
Yes, that's what
You see what I'm saying? So when you start to approach it like that, you start to abandon your fear of death. When you abandon your fear of death, you start to see the Maya for what it is. You start to see through the illusion of time, the illusion of pursuit of money, the illusion of the ego. We start to see through this stuff, and it's like it don't have no effect on you. So then we start to remember and put ourselves back together, remember our divinity, and walk in that divine light like we were put here to be. I'm really saying this stuff from a spiritual / scientific, because I'm in this platform of your professor. I always put a scientific spin on it, because that's my PC to make sure everything's politically correct and I can stand by what I'm saying. Everything that I said, there's science to back it up, like experiments, research, and stuff like that. So that's why I lean on Deepak Chopra, because he uses science to talk about these things that we can't really see. So that's why I study mathematics. It's so much fun. It's like when you look at it, you're like, oh my God, what is really going on? It's really cool. So
that's how I really felt. Well, my
So that's let's just kind of, if you have a question or a statement, just write it down. I really want to kind of focus and do my best to get through this section so that way we can be ready for our exam on Tuesday, and then with whatever time we have remaining, we can have a discussion about this kind of stuff. Also, be sure to do your exit ticket. I can't stress it enough.
Oh, yeah.
So okay. So, but yeah, any kind of statements or anything, just write them down. And I'm glad I got that on a recording of that because I've been intending to do that for a long time. Okay, so we're going to let that be because it makes perfect sense. Every time I look at these ideas, I can't, it doesn't not make sense, if that makes sense. Anyway, okay, I think we did this. We verified all the solutions. So now the way they're verifying it, they look at the graph. They graphed cosine of theta, and then they graphed the line y equals root 2 over 2. And it's going to cross at all of the points that we just found. All right, so we're going to let that be. All right, let's try another one. So we're asked to solve this equation and list out all the solutions from 0 to 360. Okay, is this okay? Is this okay so far? So let's solve this equation. I'm going to get a copy of this and load it into my notes. So these notes that you see me doing, I can actually load a copy before I walk out of the class. I'll load it into Box, and I'll make sure that we all get a copy, especially if you remind me. I'll make sure that we'll get a copy for our viewing pleasure later. Okay, and I'm going to go back to my paper and turn on my graph paper. Okay. So we're asked to solve this equation. All right, so let's get a copy. What color are you feeling? Okay, that's fine. All right, and yeah, that's fine. Okay, so here's a copy of the original. We have 2 sine theta plus the square root of 2 equal to 0. And we want all the solutions from 0 to 360. I think I'm going to attempt to do this in radians instead of degrees this time. Okay? So now, we have this equation. We have 2 sine theta plus the square root of 2 equals 0. What do you think is the first thing we need to do if we wanted to solve this trig equation? I'll give you a hint. We want to isolate something. What do you think we need to isolate?
The theta.
Before the theta, a little bit. The trig function, right? So let's isolate that trig function. How can we isolate that trig function? What? And then what? Okay, so if we subtract square root of 2 on both sides, we'll get the following. We'll get 2 sine theta equals negative square root of 2. Is that okay? And then if we divide both sides by 2, we'll get sine of theta equals negative square root of 2 over 2. Okay. This is a good one. I'm so glad. However it comes out, it comes out. Okay, I'm going to let it be, though. So now we've isolated the trig function. Now, if we think about the unit circle, is sine analogous or synonymous with our x value or our y value? So sine is like our y value. So sine is y. Now, this result is negative. So in which quadrants is our y value negative? Does that make sense? So y is negative in quadrants 3 and quadrant 4. Is that okay? Okay, so what that means is that we should have a quadrant 3 solution and we should have a quadrant 4 solution. So now, sine of what angle gives us 45, root 2 over 2, sorry. 45 degrees, right? Because I kind of said the answer. I was thinking the answer. I was trying not to say it. So we just did this, right? So we need to be 45 degrees away from the x-axis in quadrants 3 and 4. So what's 45 degrees away from the x-axis in quadrant 3? So say this is 0. Here's 90. Here's 180. If we're in quadrant 3, what's that quadrant 3 solution? That's the quadrant 2 solution, what you just said. But that's not a solution here because that's going to be positive. So, how did you get 225? Right? Okay, so instead of saying 270 minus 45, let's do 180 plus 45 so we can get that proper reference angle. Okay, let's do a quick demo on radian measure, right? So let's look at the entire unit circle. So we're going to start with the circle, and let's fix this stuff. Go ahead. Okay.
Remember on
Mm.
When the answer was in quadrant 4,
Mm-hmm.
and I did 360 minus
Yes.
45.
Mm.
So that's 270 plus 45.
Mm. You want to do it in terms of the x-axis, right? The reference angle is in reference to the x-axis, not the y-axis. So the 270 is using the y. Yeah. It's not wrong, but to be a little bit more precise, let's get rid of this and let's do another circle. We want to hit, if we're on the unit circle, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. This is interesting. So actually, when we started the class today and I asked you all how are you all feeling, you know, I think y'all say you're all excited about the holidays.
The holiday.
I was actually upset. I don't want to get into it, but I was like, well, let me let it go, and I decided to focus on your light, and then somewhere during that journey, I stopped being upset. You know, as I took charge of my emotions, I was like, let me take charge of my reality and take charge of my emotions. I brought that up. There's a reason I brought it up, but it'll come back when I need it to. So let's go ahead and make this circle. The only reason I was upset is because I was choosing to be upset. That's the only reason we have any emotion that we have is because we choose that emotion, whether it's fear or anger or joy or happiness.
So stuff comes your way and you don't like it.
You don't have to be upset. I've had elders cussing, yelling, all this kind of stuff at me, and I refused to get upset. I was like, no, I'm not upset. I'm not in that space, and so I'm just not going to go there. So I did my own little whatever I needed to do. I put up like an energetic barrier in my mind, and I was like, go ahead. But I just didn't get upset. You know, and so, and me taking charge of my emotions, that was a very powerful experience for me. Like as much, because I could have easily just felt all these low emotions. I was like, no, I'm not there. And I'm like, I'm not going to let this person take me there. You know, just like, no, I'm good. So I just let them kind of get it out, but I just used my energetic shield and I was fine. But that was a very powerful experience. I realized that I choose my emotions. I'm not a slave to my emotions. Most people are slaves to their emotions because they're not aware. And that's that whole fear-mongering thing. Okay, so now we have our circle. So now, we want 45 degrees. Now, so watch this. Let's do this really quickly. We're going to go like this. Nope, I messed up. Let's try again. From here. Where is it? Right there. That one. And then from there, that looks good. And then we're going to do, I think it's this one to this. Right there. That looks, let's go one more. Okay. So now we're doing the 45s, right? So watch this. So 45 degrees, this one is 1 pi. Here, let's do it like this. This one is 1 pi over 4. Is this okay? That's 45 degrees. Is that okay? If that's 1 pi, the first one is 0 pi over 4. Then we have 1 pi over 4. What's 90 degrees? Forget that. Do you see the pattern? We had 0 pi over 4, 1 pi over 4. What did 2 pi over 4? What's the next one? This one is 3 pi over 4. What's the next one? What's the next one? 4 pi over 4. What's the next one? 5 pi over 4. What's the next one? 6 pi over 4. What's the next one? 7 pi over 4. And what's the final one? We go back to 8 pi over 4, which is the same as 0. Do you see that? All right? So that's how we do the reference angles. So which one at the top?
The one next to 2 pi over 4.
We didn't. That's a 3 pi over 4. It goes 1, 2, 3, 4, 5, 6, 7, 8. Is that okay? Is that okay? Okay. So we want 45 degrees in quadrants 3 and 4. So now with this, if we're doing it in radians, can you tell me the quadrant 3 and quadrant 4 solution? It should be 5 pi over 4 and 7 pi over 4. Okay. So the quadrant 3 solution, so theta should be 5 pi over 4. And the quadrant, this is quadrant 3. And then the quadrant 4 solution should be 7 pi. Theta equals 7 pi over 4. Okay. So now, and we're doing sine. So now, that captures the quadrant 3 and 4 solutions. But then sine repeats how often? Every what? 360. What did the instructions say? Solve this equation. So we want all the solutions from 0 to 360. So if we want to generalize, so if we want a general formula, this is going to be 5 pi over 4 plus, we want to capture all the revolutions, right? So we're going to say plus 2, I usually do 2n pi. Or I usually do 2 pi n. So integer multiples of pi. And the other one is theta equals 7 pi over 4 plus 2n pi. 2 pi n. Pardon? Hello? I just added 360, multiples of 360, right? So now let's go ahead and list out all the solutions from 0 to 360, right? So we're going to say theta should equal, when n is 0, what solutions do we get? When n is 0. When n is 0. Mm-hmm. So we have two solutions. We have, let me get my cursor back. My cursor is right there. Let me get a copy of this. Copy. All right. One general one. Here's the other general one. Right? When n is 0, what's the first solution? 5 pi over 4. What's the other one when n is 0? Okay. So when n is 0, the first solution we get is 5 pi over 4. And the second one is 7 pi over 4. Now let n be what? Let n be 1. When n is 1, we're now what? Outside of what? We're outside of 360 because we just want the solutions from 0 to 360. Is this okay? So my claim is that these should be all the solutions from 0 to 360. I'm going to go ahead and make a box. Hang tight. So I want to box this solution. That looks good. And I'm going to do style. I want my box to be a little bit thicker, kind of like that. Undo, and like this, like that, like this. Boom, just like that. Okay, so now our claim is that these are all the solutions for this from 0 to 360. Let's get a copy of the original and check our work. So we actually have it. Let's just get a screenshot. Let's just use that one. So here is a copy of the original equation, and we're going to check our work really quickly. What technique do you think I'm going to do? Use my what? Rusty, dusty, trusty calculator. I'm just going to, just for the sake of time, I'm just doing that, just trying to be quick. So I'm going to, it's not there, it's here. Just like that. Go like that. Okay. So now let's check this. We got it in radians. So this still does have a pitfall, but I'm going to go paper. I'm going to get rid of those lines. Okay, that's better. Now, I mean, there are pitfalls. There's a lot of pitfalls, but we can at least check that the numbers that we've generated so far are correct. So we're going to go y equals, I think it's already in radians. We're going to hit 2 sine x plus the square root of 2. We're going to quit. Okay, so we have the original. So now we're going to check these results that we got. So what we're going to do, I'm just going to go variables, y variables. Now we're saying mode, we're in radians. Okay. So when x is 5 pi over 4, from the original, what should be the output? If we input 5 pi over 4 into the original, what should be the output?
I was going to say 0.
Awesome sauce.
Oh, it is?
Okay. Again, you know the stuff. You just don't know that you know it. So my job is to remind you of your divinity. Okay. If we plug in 7 pi over 4, what's the output?
0.
0. So at least these numbers are correct. All right. And that's about the best that we can do. So now we're confident in these results. Let's go back to the PowerPoint and see what result did they get. Okay. Let's see how do we do, and then we can entertain questions. That was actually very smooth. Okay. I like this. First, solve the equation for sine. So we isolated the sine. We got our negative root 2 over 2, which is basically 45 degrees. And you see, they got the same thing that we got. Okay, is this okay? Now, let me pause for the cause. Are there any questions? Any questions? Okay, how's that how's that exit ticket coming?
That's exactly what I was saying.
So did y'all want to ask any questions from her? You can ask some questions. Let's take a moment to ask some questions from her.
Tell me about a Cartesian plane.
What does it say?
Graph f of x equals 7 cosine 2x plus 1 and gx equals 9 over 2 are the same Cartesian plane where interval radical 0, 5.
Okay.
So
Is it like multiple choice or is it you?
multiple choice. I'm seeing two graphs.
Okay.
Like the graph of cosine. So I'm between those two.
Do you have the same numbers? Have you gotten that one? No. Do you have the same numbers?
I just pulled up Pearson.
Oh, okay. Okay, let's let me kind of do a quick, let me kind of glance at some stuff here. What slide number are we on? 12. We're about halfway. Let me try to focus on finishing this. If we have any time remaining, I'm open to answering questions for your exit ticket. Okay? So let me kind of keep pressing forward, keep working on it.
Get the verification code saying.
It's okay. All right, so we're asked to solve this equation. Sine of 2 theta equals the square root of 3 over 2 on 0 to 360. Okay, I'm just going to do this one. Okay? Like kind of like what we did. It's similar to what we did in the last example. It's a similar technique. I'm going to take it right here. So I'm going to take a copy of this, and I'm actually going to load it into here, right there. And actually, I'm going to start a new slide right here. Boom. And blow that up. But yeah, like, I might look kind of funny, but I ain't no fool. And it's like,
What?
that's just how I feel. No, that's how I feel. Like, that's I've always felt like that because I don't really fit in, but I know what I'm talking about, and I'm tired of, like, the nonsense that people choose to adhere to. Like, as far as our eating habits and some other things that we do as humans. I can't keep up with all that stuff. Like, I'm not going to intentionally. It's like, I feel like society is already gunning for me because of the skin I'm in. Like, I'm already a target. So then it's like, I don't need to be hard on myself. I don't need to sabotage myself by my diet and my exercise habits and other habits that I have. So it's like, so I do the best I can to minimize those kind of habits. Where it seems like society goes out of its way. It's like everybody's trying to escape and run from these things instead of taking the time to put them in order so they're no longer an issue. Like, a lot of people like fall into like alcoholism and a lot of other addictions because there's something in their past or their spirit that they have not resolved. And so a lot of people use these addictions to escape whatever it is they're afraid of. I know I do. But it's only like that until we sit and like, okay, wait, why do I feel this way? Why do I feel like I need this vice? And then once we figure out, well, I don't really need it, I just need to resolve this perspective, then we no longer need the vice. We no longer need the pacifier or the crutch. And then when there's no vice, then we can kind of actually get all the distractions out of the way, and we can actually focus on what we need to focus on. And so we can shine our unique light that each of us have.
So it's 5 questions?
Yeah, if that many. Yeah, I think it's 5. The time is, we got about 20 minutes, so it's still there. Okay, so while you all are working there, I'm just going to continue. This is the recording. It should still be streaming, so we're going to continue. We're actually solve this equation. So we have this sine of 2 theta equals root 3 over 2. Okay, so I'm going to go back to paper. I'm going to pull up my graph paper. Sine of 2 theta equals square root of 3 over 2. So we have sine of 2 theta equals the square root of 3 over 2. Okay. So if we use the same technique that we've been using, we've already isolated the trig function, right? So the trig function is already isolated. So now, sine of what angle gives us the square root of 3 over 2? Remember from the unit circle 1, 2, 3, 1, 2, 3? So sine, is that our x or is that our y? That's our y. So then sine of what angle gives us the square root of 3 over 2? Sine is our y, 1, 2, 3, 1, 2, 3. So that should be 60 degrees, right? So now, the same way we did the pi over 4, there's a similar one for the 30 and the 60. Let's see that one in action. I think it's just 30 and 60. I think this is how it goes. So let's see if I can generate it. So if we look at the circle, because once we figure it out, it gets easy. Actually, let me just get a copy of the one I used earlier. I want this, right? Let me get a copy of, I need this, I need that and that. I just want those items. I want a copy. I don't want a copy of that right here. Delete and paste. Okay. So we have this. Okay. So now 30. Let me think about this. So if that's 45, what's half of 45? 22, a third of a circle. Anyway, I need 30, so that's about... Anyway, so it's kind of like... I should do a calculation, but I'm just not feeling it right now. I want... It's 45, so I usually do about 30 is there and there. And let's go like this. That's fine. I think that'll work. Okay, I think that looks good. 1, 2, 3, 1, 2, 3. So then it should be a similar here. 1, 2, 3, 1, 2, 3. Nope. Something's off. Dang, what is that? Oh, maybe. Anyway, supposed to be like that. I guess I'm just trying to be a stickler, but I'm being extra for no reason. Okay, and then let's go ahead and do this one. Oh, it's probably because of that, but that's okay. Okay, that'll work for me. And then let's get rid of, hopefully this is not too much. But the 45 was simple. Let's see if we can do something similar with the 30 and the 60. Okay. So now, what's 30 degrees in radians? Just 30 degrees converted to radians. So times pi over 180, pi over 6, all right? So this is 30 degrees, which is 1 pi over 6. What's 2 pi over 6? It's not 45. Is that 60? Is that 60, right? What's 3 pi over 6? So here's the 3 pi over 6. I think that's 3 pi over 6. I think this one should be, is it 6? How many spokes do we have? 1, 2, 3, yeah. This should be 4 pi over 6. This should be 5 pi over 6. This should be 6 pi over 6. This should be 7 pi over 6. 8. Yeah, right? Which is 2 pi over 6. Is it agreed? All right, okay. So then we did 7. We should do 8 pi over 6. This should be 9 pi over 6. 10 pi over 6. 11 pi over 6. And we started with 0 degrees, which was 0 pi over 6, which is this. And that's also going to be our 12 pi over 6. Okay? Is this okay? Okay?
So why is this number?
Because we're doing by third. A sixth each time, 1/6, all right? So when you think of 30 degrees, what color comes to mind? Pink for 30 degrees?
Pink for 30 degrees.
That's fine. That's what he said. So that's 30. What else is 30? Hang on. So I know this one is 30. Style, pink. This one is 30. Style, pink. This one is also 30. And let's just go ahead and do that one. Style, pink. So that means this is also 30. Pink. I think those are the 30 degrees. So then when you think of 60 degrees, what color comes to mind? Give me something more bright. Okay, let's do gray. All right, so when we do 60, we'll do style. That's okay. That's That's what we need. Like, we don't need everybody to be the same, because it's that energy that where genius and creativity and like if everybody was the same, we wouldn't have iPhones. It's the truth. Well, it's not a joke. That's the truth.
Oh my God.
Right. Like if we didn't have, if everybody was tall, we wouldn't have any. You know, we wouldn't know if we were all short or all tall. If everything was the same, so we need the diversity to appreciate, you know, whatever we want. So all the grays are 60 degrees. Is that okay? Those are the reference angles. I think this is okay. This looks okay. So now with this is in radians, but notice how I built it. I just said 1, 2, 3, 4, 5, 6 until I got to 12, right? So now with that, so now we said root 3 over 2. We said that was what, 60 degrees, all right? Now, sine is our y. Y is positive in which quadrant? Why are we taking positive y versus negative y? If sine is our y and the result is a positive square root of 3 over 2, so that means we need to find the positive y solutions. Y is positive in which quadrant? 1 and 2. Okay. So that means we should have a quadrant 1 solution, and there should be a quadrant 2 solution. So sine of what angle, let's focus on quadrant 1. Sine of what angle gives us square root of 3 over 2? From the unit circle, 1, 2, 3, 1, 2, 3. Hello?
Huh?
Sine of what angle gives us square root of 3 over 2 from the unit circle? 60, right? 60 degrees. Do you see 60 degrees on this circle that we have?
Oh, yeah, I see it.
Right? Okay. So that's really what, pi over 3, right? So then what we're saying is that, so we say 60 degrees. So we're saying that 2 theta needs to be basically this pi over 3, the 60 degrees. Does that make sense? So if we took sine of that angle, so let me see, it should equal, sine of that angle is going to give us square root of 3 over 2, so that angle needs to be the pi over 3. So then if we go ahead and solve for theta, let's go ahead and do our repeating. So now if we're at 60 degrees, how often does sine repeat? Every what? So we also got to account for the repeats. So we're going to say plus 2 pi n. So that captures all the repeats for 2 theta. Let's talk about the quadrant 3 solution. So if that's the quadrant 1 solution, sorry, let's talk about the quadrant 2 solution. So what's 60 degrees in quadrant 2? 4 pi over 6, which becomes what, 2 pi over 3, right? So the quadrant 2 solution is going to be, this angle needs to be equal to 2 pi over 3 plus 2 pi n, integer multiples of pi. So this captures all the solution. The question asks us, we want all the solutions from 0 to 2 pi. Okay, we want all the solutions from 0 to 2 pi. So if we got 2 theta equals pi over 3 plus 2 pi n, and we also have 2 theta equals 2 pi over 3 plus 2 pi n, 2 pi n, okay? Let's go ahead and solve for theta. So if we're working the equation on the left, if we solve for theta, what do we do to both sides? If we want to get the theta by itself. So what's the inverse operation for, if we said 2 times theta, what's the inverse operation? Divide both sides by 2. See, I told you taught me something. I'm not gonna stop. I'm gonna keep saying inverse operation. So if we divide both sides by 2, we eventually have to do something like this. Those are gone. And we'll finish with theta equals, what is that? Pi over 6 plus n pi, or pi n, right? And if we do the other one, if we divide both sides by 2, let's see, that's gone. I think these cancel, and those are gone. We'll finish with theta equals, we got pi over 3 plus n pi. right? So now let's capture all the solutions from 0 to 360. So then theta should be equal to, now when n is 0, what's the first solution? If n is 0, we get pi over 6. What about the other one? We get, when n is 0 on the other one. Pi over 3, okay. So then when n is 1, when n is 1, what's 1 over 6 plus 1? 7 pi over 6, right? Is that right? So that's going to be 7 pi over 6. And then the other one, when n is 1, what do we get?
No, I'm still trying to understand the first one.
Okay, let me see. Do I still have a copy of my cursor? No, let's undo. My cursor. Hang on. Let me get a copy of the cursor. There you are. Let's copy. Now let's look at this. So what I'm doing is right here. So we have these solutions. So right here. At this one, I let n be 0. That means this is gone. That's where that pi over 6 came from. When I let n be 0 here, this term is gone. We just got the pi over 3. All right? When n is 1, it's basically 1 over 6 plus 1. It gave me 7 over 6. So what is this one going to be? If n is 1, it's going to be 1 over 3 plus 1 gives us, okay. So that's going to be 4 pi over 3. So when n is 2, what happens? Because if we want all the answers from 0 to 360, what happens when n is 2? Well, we're outside of the 360. Once n is 2, we've gone too far because we only want 0 to 360. Does that make sense? Yeah, the question says we only want the results from 0 to 360. Right there. 0 to the 360, okay? 2 pi is 360. I just know that 360 is a little bit easier to see. So my claim is that these are the solutions. Let me... Okay, so now if my claim is that these are the solutions, let's just check that in our calculator really quickly before we go back and check our answer. Okay, so now the original sine of 2 theta, okay, so we should finish with the result of square root of 3 over 2. Okay, so let's go ahead and find that decimal. If we did the square root of 3 divided by 2, we get this, right? So if we said sine of 2 times, the first one is pi over 6. So I'm going to say pi over 6, double close. We should get that same decimal. We're good. I'm just going to recall. Now we're going to do sine of pi over 3, or 2 times pi over 3. We should get the same decimal. We're good. Now we're going to recall, say sine of 2 times 7 pi over 6. Insert 7 pi over 6. We're good to go there. And the final one, 2 times 4 pi over 3. We should get the same decimal. Okay? So just showing you that it's possible, okay? You're responsible for this, okay? We got to keep moving. Okay, I feel good with that. So I'm going to go back to the slides really quickly because we're just about out of time, so I'm just trying to wrap it up. Okay? Just want to make sure we got the same results they did. We should. Pi over 6, pi over 3, I think we got those results. We can do a quick glance. I'm going to have to leave this as an exercise for you. See if there's anything I can see. Using a calculator, I'm going to have to leave this for you. Okay. There is a little bit more that we need to talk about, but I'm going to have to leave it for you because we're out of class time. Okay? Solve trig equations and quadratic equations in quadratic form. Yeah, I'm going to have to leave this because we're out of time today. Let me just get to a blank page. I'm going to go here. Let me go to paper. So at least what we talked about, I can go ahead and load the stuff that we've done together. So I'm gonna go ahead and share. I'm gonna go to box. This is, let's see, this is the fall. This is pre-calculus, entire class. I'm gonna put it into the notes. Actually, before I send it there, this was 6.3 Trig Equations. So let me write that down. This is 6.3 trigonometric equations. Awesome. Okay, that's fine. So I'm gonna hit share, send it to box. This one, fall, pre-cal, course files, into the notes, send it there. Okay. So when this loads, you'll have a copy of anything that you saw me writing in the notes. You'll have a copy of it as soon as this bar finishes loading. Okay, let me pause for a moment. So did you all want to ask any questions about anything? Any questions? So it's going to take some practice, right? With this, so were y'all able to get through the? Were you able to get through the exit ticket?
I'm on number 4 now.
Is that the last one?
I got one more.
So we still got a solid 5 minutes. I'm open to answering any question that you want.
Okay, let me go back.
So if you can ask any question that you want right now, we'll talk about it. I'll take it to the all the way to the end.
Boom. It said, what are the domain and range of y? So secant, is that how you say it?
Okay, hang on. It says, what is, so, okay, read the original, because we got 5 minutes, so.
What are the domain and range of y? Y equals secant x.
It says y equals secant x, like that, domain and range. Okay, so with this is how I do this one. Secant is the reciprocal of what?
Wait, don't nobody say it.
Wait.
Is it sine? No, it's cosine.
There it is, because it's the opposite kind of thing, right? What color are you feeling? Give me a color.
Green.
Okay. So secant is a reciprocal of cosine. So first I'm going to look at cosine of x, right? So remember, what did the question say again?
What is the domain and range of y?
Okay, so let's start by looking at the graph of cosine, right? So really quickly, if we do a quick glance at the graph of cosine, right? So we have the 5 key points. Come on. So say this is the max, say this is the min, this is 1, this is -1. Let's do this in 1, 2, 3. 1, 2, 3, there's 1. 1, 2, 3, there's 2. 1, 2, 3, there's 3. 1, 2, 3, there's 4. All right. Let's do this in degrees really quickly. This is 90, 180, 270, and 360. Is this okay? If we're graphing cosine, no. Go away. If we're graphing cosine, tell me about cosine. Tell me about the graph of cosine? Cosine, does it start in the middle? Does cosine start at the middle, the max, or the min?
Cosine start at the max.
Okay, so here's the first point for cosine, then it goes where?
It goes down.
To the middle, and then it goes to the
bottom.
to the minimum, and then back to the
middle.
and then back to the max, which is here. Okay? If we connect it with a smooth curve, cosine looks like this. Is that okay?
Mm-hmm.
So this is cosine of x. So then when we want to look at the graph of secant is the reciprocal of cosine, right? So if we flip 0, what color you want to do for secant?
Brown.
Brown, okay. So when we flip cosine, when we flip a 0, what happens? It becomes? Undefined. So the zeros of cosine are the asymptotes, and let's make it a little bit thicker just for contrast. I'm going to go like this. So when we flip this, the zeros become our asymptotes. This is also an asymptote. And then all we do is, and we still pass through the same max and the min value points. So we're still going to pass through these points here. And then we just make a U. So the U is kind of going to go like this and finish close there. This U is going to kind of come like, if this continues like this, all right? that you was going to start down here, pass through that point, and finish close to this. Is this okay? This is the graph of secant x. Is this okay? Starts close, passes through, and then it's going to continue. And let's redo this one. Again, passes through there and finishes close. So the brown is the graph of secant. Is this okay? I feel like I made a mistake. It looks okay, right? Is this okay? Yeah. Okay, so now with this graph, how far left does this graph go? Or what's the domain? We include everything except what? Where are the asymptotes? Where's the first asymptote?
It's 1, isn't it?
What's the x value? The first asymptote occurs at 90 degrees, right?
Yeah.
So it's the domain of this is everything except odd multiples of pi over 2, right? So the domain is going to be all reals, everything except we're going to have n pi over 2. Let me think about this. The domain is going to be all reals except theta, where theta is not n times pi over 2, where n are odd integers. Okay, so what are your options for your answers? Is it multiple choice? Mm-hmm. What are your options? You have a class after this?
Oh my Jesus.
So since we're still streaming, for anybody that's listening, again, this goes out to any of my students. I'm still open to offering extra credit for each hour spent in my office hours during tutoring. I'm open to extra credit for that. Okay? Mm-hmm. So if you want some points, just spend some time in my office getting some tutoring. I still need to add some points for some students I had yesterday, but that's fine. So what are your options for your answer choices on that question? Oh, is it going to let you keep going? You have yours?
Yeah.
Is yours similar or different?
It should be similar.
But the numbers might be different, right?
Mine talks about the solution set on the integral.
What's the original question?
It says solve f of x equals g of x on the interval radical 0 pi.
Okay, say that again. Say it again.
Solve f of x equals g of x on the interval bracket 0, comma, pi. They're brackets.
The both are brackets?
Yeah.
Or is it a bracket and a parenthesis, or are they both brackets?
Both brackets.
What's f of x and g of x?
F of x is just the x value and g of x.
Wait, let me see the original. We're out of time. Can you just like bring it over here? Are you able to take a screenshot? Can you like airdrop or email?
That's exactly what I was trying to do, but like
on my phone.
It's okay. Okay, let me see. Where is it? So it says graph. You talking about part A?
Well, I'm talking about part B. I just want to show you.
Let's see. It says the solution set on the interval 0 to pi is. So they want the solution to this. So back at the original.
So like these. So this.
Oh, so the solutions, right?
So, like,
Where's your f and your g? I need to see. F is here. It has 7 cosine of 2x plus 2. G is 11 over 2. So then basically we set them equal to each other and solve, right? Okay, so let's do it really quickly. Okay, wait. So f of x is, it says 7 cosine of 2x plus 2. And then g of x is what, 11 over 2? Okay. And then it says graph this on the same plane. It says solve f of x equal to g of x on 0. It says 0 to pi. Okay, so we want to solve. Okay, so I think we got it. I'll do my best with this and then we'll wrap it up. So you can have a seat, yeah. So now, basically it's saying we need to solve f of x equal to g of x, right? So what we're going to do, let's do 7 cosine of 2x plus 2. We want to set that equal to 11 over 2. And we want to get all the solutions from 0 to pi, right? So with this, what we do first, we isolate our trig function. So if we get the trig function by itself, ultimately what we're going to have, on the left, we're going to have cosine of 2x. If we subtract 2 and divide by 7, we're going to have 11 over 2 minus 2 divided by 7. We need to simplify that number. So that's going to give us cosine of 2x. Let me see, 11 over 2 minus 4 over 2 is what? 7? 7 over 2? 7 over 2 divided by 7 is just 1 over 2. All right? So now we're saying cosine of some angle equals a half. On the unit circle, cosine of what equals a half? Cosine is our x. What is it? 60 degrees, right? So then this is positive. Cosine is our x is a positive. So there should be a quadrant 1 solution, and there should be a quadrant 4 solution. Okay? Give me a moment. I'm just going to wrap this up. So then 2x should equal, we said 60 degrees, pi over 180. So that's going to be pi over 3 plus 2 pi n. Is that okay? These are, I'm going to find all the solutions, and then we're going to come back and find the one specific to what we're looking for. The quadrant 4 solution, we said 60 degrees, so that's going to be, if I go back here, the gray is 10 pi over 6. I'll do 10 pi over 6. So then 2x needs to be 10 pi over 6 plus 2 pi n. Give me just a moment. Do you have, is it multiple choice or fill in the blank? Okay, so if we bring it on home, x equals, we got pi over 6 plus n pi. This one, x equals 5 pi over 6 plus n pi, okay? So then we want all the solutions on 0 to 180. So when n is 0, we get just pi over 6. When n is 0 there, we get 5 pi over 6. And then when n is 1, we're outside of the range. So let me just check that these two actually work in the original, and then we'll call it a day. So the original is right there. This. Let me get a copy. I'm about to let you all go. Okay, hang tight. Let me just check this really quickly. So I'm going to put this in my, daggone it. I'm trying to keep that to stay there. Come on. Hang on. There it is. That's fine. Let's just do a quick whatever, okay? So now we're going to go to y equals, clear. I'm going to hit 7 cosine of 2x, close parentheses, plus 2. I'm going to quit. I'm going to go to variables, y1. Now, when x is pi over 6, 11 over 2 is 5.5. We should get 5.5. Awesome. And then when x is 5 pi over 6, we should get 5.5 again. Oh, I'm hitting the wrong thing. 5 pi over 6, and we should get 5.5. So we can stand by those results. So that should be all of them, okay? Okay, so any questions? So because I got to let you all go. Any questions? Okay. So let me go to paper. I'm going to leave it open. So if you want to do it again, you can, because I'm probably not going to look at it right this second. It's a good idea to just let your classmates know to watch the video, and if they submit theirs and I haven't updated my grade book, I'll take whatever grade is there. Okay. Let me go ahead and load a copy of this again since we made an update to that same folder. It's in the box. Come on. And it should ask me to overwrite. If it does, I know I did something right. Okay, so while this loading, any other questions, you all? So there is a study guide, okay? So you definitely want to... Yeah, the PDF should be on Moodle, but there's also a soft copy that's on Pearson. So you just need to work one or the other. On Tuesday, what we need a number 2 pencil. We need a number 2 pencil, whatever calculator we intend on using, a homework notebook, and our sheet of paper. Our one cheat sheet. You can write anything you want on the front and back of that paper and use it on the exam. Okay? Any other questions, comments, or concerns? That was a fantastic day. Yes. That was way smoother. That was way, well, no, because I actually had some rest. I took charge of my rest cycle. I had to just, Okay, lovely people. I'll see you. Good luck. I'm available on the weekend if you have questions. I'll see you Tuesday. Good luck. All right.